Recursion is a powerful technique that can simplify complex problems and make the code more elegant. Let's start simple. The n factorial is this product here. Usually the first solution is this, or that. They all are good and very efficient, but let's try something new, recursion. First, decompose this problem for smaller one. Let's write a new VI. Clear definition of the function is essential. So input is n, output is n factorial. Connect input and output. Create the appropriate icon. And save as factorial. Now the code. Define the base case to prevent infinite recursion. For us, it's this. When n equals 0 or 1, the n factorial equals 1. Then the second case, when n is greater or equal to. We multiply the n and n minus 1 factorial. Factorial is our function, so just drag and drop it here. It's grayed out. It's because it's set to be non-reentrant, which prevents concurrent call. Let's change it here. Recursive call requires the VI to be reentrant with shared clone. Now the program is ready to execute. Remember to always define the basic step where you don't call the recursive VI, and to change the input to the function for each recursive call. Check if it works. Now you can use it in another VI. The second example is less trivial. Let's say we have a folder which has some files and other folders inside. We want to know the path of every file in this folder and all subfolders. So let's do this. Our input is the folder path. The output is an array of files. Connect terminals. Now create an icon showing the function purpose. Save as list files in folder. Now diagram. The functionality we want to write already exists, and you can find that function here, in File Functions. It's quite complicated, and as you see, it's not recursive. Now let's do it the easy way. Let's list our folder for files, and, for every file, build the path pointing to it. For loop with indexing tunnel is good for the job. File paths are placed inside the indexing tunnel. Now this function outputs an array with files inside this folder. It's also our basic case, where we don't make the recursive call of our program. Then let's repeat this basic functionality for every subfolder in our hierarchy. For loop allows to iterate for each subfolder. List files of a folder with recursive call of our program. It's not reentrant by default, so change it again here. Add the list of files together. Use concatenate option of the tunnel. And also concatenate here. That's it. So easy, and indeed, more elegant. Note that when certain folder is empty, this for loop will not execute, so recursive call will end. As you see, recursion brings a different perspective on problem solving and can express the logic of a problem in a natural way without using loops or variables. Exercising your view this way may be valuable for future. In Part 2, we'll discuss dynamic programming, recursive call with memoization.